Welcome, curious minds, to another Deep Podcast. Today, we're plunging into a world that, for many, is really the epitome of relaxation and rejuvenation. We're talking about the intricate, deeply satisfying realm of sauna design and construction. And look, this isn't just about building a hot box, it's about crafting a truly elemental experience, maybe even a personal sanctuary. It's rooted in this fascinating, often surprising blend of physics, ancient tradition, and, well, pure comfort. We've compiled a huge collection of sources for you today. I mean, everything from historical notes that give us a glimpse into, the origins of sauna culture, all the way to modern engineering simulations that figure out exactly how heat moves. Plus, some incredibly practical guides from the experts and manufacturers who really live and breathe this stuff. Our mission, as always, is to cut through that information overload and equip you, our listener, with the core knowledge and maybe some truly unexpected insights you'll need to understand what makes a truly great sauna. So, okay, let's unpack this.
Yeah, and what's truly fascinating here is how much traditional wisdom, honed over centuries, aligns almost perfectly with cutting-edge scientific principles when it comes to building these things. Our goal today is really to provide clarity and context, help you navigate the nuances of building a sauna that doesn't just get hot, but truly delivers on its promise of deep well-being. We're going to help you connect the dots between those time-honored practices and our most current scientific understanding so you can fully appreciate the profound thought and care that goes into designing your own personal sanctuary.
Exactly. Okay, let's start with the blueprint, understanding the dimensions, the layout.
Right.
Let's kick things off with a little historical perspective that might just surprise you. When we picture a sauna today, we often think of a cozy, contained space, maybe just big enough for a few people. But would it blow your mind to learn that historically saunas were often quite grand? Seriously, we're talking about structures that frequently range from 15, 20, or even up to a massive 40 square meters.
40 square meters, imagine that.
Right, almost the size of a small apartment. And this isn't just some historical footnote, it reveals a profound shift. The surprising truth is that the shrinking of saunas isn't just about making them fit into smaller modern homes, though that's part of it. It's also about a subtle yet significant shift from these big communal rituals where entire families or groups gathered to a more individualized wellness experience. But, and this is key, sometimes these smaller, more modern designs compromise on that delicate balance of heat and steam dynamics. A lesson we'll really unpack next.
It absolutely does tell us so much about changing lifestyles and priorities. Today, for most domestic saunas, the ideal size we typically see is much more modest, generally hovering between, say, 4 to 5 square meters. And for those with even more limited space, effective, though undeniably smaller, saunas exist, maybe in the range of 1.5 to 2.5 square meters. These dimensions aren't just random numbers either. They're deeply tied to comfort and efficacy. So when you're planning your own build, think about this. We recommend a minimum of 3 cubic meters of space per person. That's the minimum.
Okay, 3 cubic meters per person.
But for a truly comfortable, well-designed, self-built sauna that allows for proper air and steam circulation, good practice suggests aiming for a more generous 4 to 6 cubic meters per person. Why this matters to you is that these figures are your crucial starting points. They guide your initial space allocation, helping you avoid common pitfalls. Make sure you're setting yourself up for an enjoyable, expansive, not cramped experience. Without these guidelines, it's incredibly easy to misjudge the scale needed for that truly authentic, uncompromised feeling of warmth and, well, spaciousness.
So, okay, saunas have shrunk, but here's where it gets really interesting and surprisingly uncomfortable if you get it wrong. You might think, smaller sauna, less to heat, what's the big deal, more efficient, right? But an undersized sauna comes with some very real and, frankly, quite unpleasant practical drawbacks. Just imagine trying to relax when you're constantly too close to the stove.
Oh yeah, that direct heat.
That intense, uneven blast of direct radiative heat can be incredibly unpleasant, almost like standing in front of an open furnace door, but worse because in a small room, it's inescapable. It just doesn't allow the heat to mellow out and circulate evenly. And it's not just the radiative heat. If the sauna is too small, the steam, that wonderful loily, as it's traditionally known, it doesn't have enough space or time to dissipate properly. So instead of this enveloping, gentle wave of humid heat, it ends up feeling, well, the sources say, too aggressive. It hits you with a harsh, concentrated burst that can be jarring, not soothing at all.
Right, and that aggressiveness you described, it's a direct consequence of the physics at play within that confined space. The interaction between the intense heat radiation coming straight off the stove, the convection current swirling the hot air around, and the delicate diffusion of steam through that air. It's incredibly sensitive to the volume of the room. In a smaller volume, These elements just don't have the necessary room to distribute and blend properly. The vapor cloud, instead of mixing smoothly and humidifying the air uniformly, it just stays concentrated and dense near its source. This directly impacts the overall thermal distribution, creates stark differences in temperature and humidity, and as a direct result, it profoundly affects the user experience. Understanding these dynamics helps you truly appreciate why even a few extra square feet, or really cubic meters, can make all the difference. It's the difference between a harsh, overwhelming hot room and that authentic, comfortable, truly therapeutic sauna experience where the heat and steam work together, preventing that feeling of being overwhelmed. #ChatTag 1.3, optimal geometry and structural flexibility.
Okay, moving from the overall size to the actual shape. You'll find that saunas typically have a very practical square or rectangular base, which makes a lot of sense, right? Not just for building efficiently, but also for ensuring even heat distribution and smart placement of benches. But there's a key piece of advice here, something easily overlooked. You don't want to stretch the sauna too much in one direction.
Like a long, skinny room.
Exactly. The recommendation is to keep one side no more than 20%, or maybe at most 40% longer than the other. If you go beyond that, you risk creating significant temperature differences, uneven heat distribution. You get uncomfortable cold spots and overly hot spots that can really diminish the experience. Some areas might be almost unusable.
And while those basic shapes are common and practical, there's also surprising room for, structural creativity in sauna design. For instance, it's entirely possible to build a sauna with 2 levels, almost like a mezzanine.
Oh, interesting. Like bunk beds, but for heat.
Sort of. It offers fascinating design possibilities, maybe creating different heat zones, a cooler lower level, hotter upper one, or just for a unique look.
Oh.
But if you opt for this, there's a critical design detail you absolutely cannot overlook. This mezzanine must be very porous. What that means is significant gaps between the planks are absolutely essential. You need to let the hot air circulate effectively throughout the entire volume of the sauna. Without those gaps, you'd end up with stagnant air, uneven heating, and a frustratingly inconsistent experience. It's a prime example of how form absolutely must meet function here. You need proper heat flow for a consistent, enjoyable experience for everyone. This insight really offers creative design possibilities while making sure thermal efficiency and comfort aren't compromised just for a unique look. #TagTag 1.4 Foundation for Outdoor Saunas.
Now, if you're like many of our listeners, maybe dreaming of an outdoor sauna, a beautiful freestanding structure in the backyard, perhaps by a lake or pool, if that's the case, there are some very specific, crucial things to think about for its foundation.
Indeed. For outdoor saunas, positioning the structure on a reinforced concrete slab is significantly preferable to just placing it directly on the ground. And this isn't just about over-engineering, it's about long-term durability and performance. There are several key reasons. Firstly, it ensures superior stability, prevents the structure from shifting, settling unevenly over time due to ground movement, or, being affected by freeze-thaw cycles.
Right, keeps it level.
Exactly. Secondly, and very importantly, it acts as a robust barrier against ground moisture. This helps manage humidity, preventing moisture from wicking up into the wood structure that could otherwise lead to rot, mold, or just an unhealthy environment inside the sauna. And finally, a proper slab greatly enhances the overall durability, protects its base from direct contact with the elements, extends its lifespan significantly. This is a practical long-term investment tip for anyone building outdoors. Ensures your sauna stands strong, healthy, and, pristine for many, many years.
All right, let's transition from the macro design elements down to the micro, starting with what's literally underfoot in your sauna. Sauna floors are typically constructed from either wood or tiles. Now, while floor temperatures are generally quite low and comfortable, usually safe to walk on, it's a critical detail that excessively hot tiles can cause burns. Imagine stepping out of the heat onto a scorching floor, not exactly relaxing.
Definitely not.
So while aesthetics play a role, practicality and, most importantly, safety are absolutely paramount here.
Absolutely. And beyond the material choice, we need to consider critical functional aspects, like drainage and inherent safety features. An optional but often incredibly useful addition for floor drainage is to incorporate a gutter or channel for water runoff. Now, this isn't necessarily crucial if your sauna use is primarily dry, but it certainly proves its worth if you envision dousing the stones heavily, or maybe even using buckets of cold water for a quick rinse inside.
Ah, okay, for the full wet sauna experience.
Right. However, what is non-negotiable for any sauna floor, regardless of material, is that it must be anti-slip. This is a crucial safety element, designed to prevent accidents in what will inevitably be a wet, steamy, sometimes dark environment. Slips and falls are a serious risk, so prioritizing a textured or naturally grippy surface is key. So when you're making these decisions, remember, safety and longevity start literally from the ground up. Thinking about these seemingly small details now can prevent a lot of headaches, costly repairs, and potential injuries down the line.
Okay, let's unpack this for the interior walls. This is arguably the most visible, tactile, and aromatic part of a sauna's interior. And the choice of wood is absolutely critical, not just for looks, but for the very essence of the experience. Interior walls are almost universally made of wood that's just part of the tradition. Now, you might be tempted by pine. It's economical, widely available, but be aware, pine can produce resin drips at high temperatures. And trust me, you don't want sticky, sizzling resin in your sauna.
Yo, definitely not pleasant.
The true star, considered ideal by many, is aspen, sometimes also known as trumbull. It's prized precisely because it doesn't produce resin, offers a clean, consistent, neutral experience. On the flip side, some woods are simply not recommended for sauna interiors, like redwood and eucalyptus, often due to their oils or volatile compounds. But there are many other suitable options out there: alder, Monterey pine, various red cedars, spruce, magnolia, hemlock, or abachi. Each offers a slightly different grain, scent profile, feel.
And this brings us to a very, very important point regarding the wood's treatment. It is simply not necessary to treat the wood inside the sauna with any finishes or sealants. Furthermore, and this is absolutely crucial for your health and safety, toxic products, paints, or varnishes should never be used on interior sauna surfaces, ever. Why is this so vital? Because the high temperatures inside a sauna can cause chemicals or volatile organic compounds, VOCs, to volatilize, turn into gas, which then impacts the air quality you're breathing and consequently your long-term health.
Right, you're breathing that stuff in.
Exactly. Imagine the distinct, sometimes acrid smell of pine resin dripping and sizzling. Or worse, the fumes from a chemical treatment versus the clean, neutral, calming scent of natural aspen. This seemingly small choice profoundly impacts the sensory experience, contributes significantly to the feeling of purity and well-being you seek. Opting for untreated, non-resinous wood ensures you're breathing nothing but clean, warm air in your personal sanctuary.
Okay, this next point is a bit counterintuitive when we talk about interior wall thickness. It's one of those surprising insights. You might instinctively think thicker is better for insulation, but that's not quite the case for the interior wood panels themselves. In fact, the interior wall shouldn't be too thick. Why? Because it will absorb a lot of heat, which in turn significantly slows down the initial heating phase of the sauna.
Acts like a heat sink.
Exactly. We want that room to get hot efficiently, not waste energy warming up the wood itself. But of course, it also needs to be strong enough for practical use. Sturdy enough to lean against comfortably, but no more. It's not meant to bear significant structural stress. A functional thickness for interior paneling is typically quite modest, often around 1 centimeters, found in panels that are commonly 1.2 to 1.6 centimeters thick. If you go for an interior wall thickness of 2 centimeters or more, it's likely excessive, provides unnecessary mechanical resistance and just too much thermal mass, which, again, will definitely slow down your heating time and waste energy.
You've hit on a crucial balance here that goes beyond just thermal considerations. Beyond its role in heating efficiency, the interior wooden wall also plays a subtle but important role in acoustic dampening. It contributes to that quiet, contained, almost meditative atmosphere within the sauna, absorbs echoes and external sounds. So what this detail highlights is a crucial, multifaceted balance in sauna design. You need efficiency in heating to get to temperature quickly and economically, but you also need structural integrity for comfort when leaning back or moving around. And, importantly, you want that sound absorption for a peaceful, tranquil environment. It's about creating a space that feels robust and serene, supports your body comfortably, and most importantly, isn't sluggish to heat up, letting you maximize your relaxation time.
Now that we've deeply explored the interior, let's shift our focus to the outer layer, the exterior walls. These have a completely different set of requirements compared to the interior, mainly driven by their exposure to the outside world.
Precisely. If your sauna is an outdoor structure exposed to the elements, the exterior wall is typically wood, chosen for its natural beauty and durability. In this scenario, proper treatment and thorough waterproofing of both the exterior wall and the roof are not just recommended, they're absolutely essential. This is your primary defense against rain, snow, ice, relentless UV exposure.
The works?
Exactly, for many, many years to come. Think of it as protecting your investment and maintaining its look. If, on the other hand, your sauna is indoors, maybe in the bathroom or basement, then the exterior wall can just be a classic building wall. Could be bricks, concrete, plasterboard, whatever, and
Right.
won't be exposed to the weather. In terms of thickness, exterior walls can be as thick as needed for mechanical resistance or structure, or just to match the surroundings. Unlike the interior walls, they don't directly absorb heat during the warm-up phase, so a typical thickness of, say, 2.5 centimeters or more is perfectly acceptable, often chosen for robust construction or aesthetic consistency.
Okay, so what does this all mean for one of the most critical yet unseen components?
The insulation. For a very long time, mineral wool has been a go-to choice in construction, and saunas are no exception. Rock wool, for instance, is frequently used. It's generally less irritating to handle during installation than glass wool, though not necessarily more insulating in terms of raw thermal properties.
Indeed, mineral wool is a common and effective choice. But there's a significant modern alternative gaining considerable traction: synthetic PIR or polyisocyanurate rigid insulators. Think of these as high-performance rigid foam boards.
Okay, like those foam sheets you see. Exactly. These can effectively replace traditional mineral wools, and they come with some truly compelling advantages for sauna construction. PIR is inherently heat resistant. It won't soften, deform, or burn under the intense, sustained high temperatures typical of a sauna. It's also rigid, which can make it easier to handle, cut, and install compared to the flexible, sometimes messy nature of mineral wool bats. Crucially, and this is a major game changer for construction simplicity, PIR is water resistant and does not require a separate vapor barrier.
Wow, okay, that's huge.
It is. It can significantly simplify one of the most delicate and error-prone aspects of sauna building. The trade-off, of course, is that PIR is typically more expensive than mineral wools initially. However, it's approximately twice as insulating for the same thickness, meaning you can achieve the same thermal performance with a much thinner layer. Plus, it's simpler to install due to its rigidity, and as I mentioned, it eliminates the need for that complex and often fragile vapor barrier. So for you, this is a key decision point in your build. You're weighing initial cost against superior performance, ease of installation, and a potentially more robust, forgiving construction process. Hashtag 3.2, the critical role of the vapor barrier.
Okay, but if you do opt for traditional mineral wool insulation, then a vapor barrier becomes absolutely undeniably essential. No skipping this. We're talking about a sealed aluminum vapor barrier, which is typically placed strategically between your interior wood wall and the insulation layer. Its primary purpose is ingeniously twofold. First, it keeps the beneficial vapor, that wonderful lowly, inside the sauna for the occupants, ensures that humid, therapeutic effect. Second, and equally important, it rigorously protects the insulation itself. Why? Because wet mineral wool or glass wool loses its thermal properties dramatically, becomes far less effective, almost useless at trapping heat,
Might as well not have it.
pretty much. And here's a crucial installation detail. The shiny side of the vapor barrier must face into the sauna,
Yeah.
towards the heat. And for it to work effectively as a truly sealed barrier, every joint and seam needs to be hermetically sealed with specialized aluminum adhesive tape, preventing any vapor from sneaking past.
Right. And the reason for the shiny side facing inward isn't just about vapor management. There's a clever bit of physics at play that adds another layer of efficiency. That shiny surface is reflective. It reflects thermal radiation back towards the interior wall, providing an additional boost to the sauna's heating efficiency, like a tiny heat mirror.
Ah, clever.
It is. But beyond vapor and radiation, the barrier also serves a third function. It limits cold air infiltration, effectively acting as a thermal insulator in addition to its primary role as a vapor and radiation screen. And here's another subtle but useful detail. It can be beneficial to leave a small, deliberate 10 mm breathing space or air gap between the interior wood wall and the insulation. This allows for any minor inevitable moisture to dissipate safely, helps prevent condensation issues, and ultimately ensures the entire system works as intended. Keeps your sauna dry and efficient from the inside out. Hashtag 3.3 insulation thickness and the counterintuitive truth of heat transfer.
Let's talk practical thickness for mineral wool insulation. Typically, you'll see recommendations for 5 centimeters to 10 centimeters with a minimum of maybe 4.5 centimeters. Now, this is where it gets really interesting and, frankly, a bit counterintuitive again. Sometimes more isn't always better. Going thicker than 10 centimeters is probably unnecessary. And here's the kicker. It actually becomes more costly, and surprisingly, it won't significantly speed up the heating phase of your sauna. This seems to flip what many of us think about insulation, doesn't it? Like, more should always be better.
It absolutely does seem counterintuitive. And that's because we often think of insulation as simply trapping heat indefinitely, like a thermos. But the physics of heat transfer in a sauna environment, especially during that crucial warm-up phase, tells a surprisingly different story. Think of it like trying to heat a very thick, dense blanket. The heat slowly creeps through. Mineral wool, for all its excellent insulating power, has a very low heat creep factor, or thermal diffusivity. Around 10 near canalaceous, this means heat doesn't penetrate deep into the insulation quickly. Even after 1 to 2 hours of heating, heat won't penetrate more than about 12 to 17 centimeters into the material. The maximum thermal gradient, where the biggest temperature difference occurs, is concentrated in the first few centimeters during that transient heating phase. This makes additional thickness beyond a certain point somewhat superfluous in terms of speeding up the initial warm-up.
So piling on more insulation doesn't make it heat up faster after a point.
Exactly. And what's truly fascinating here, this is the big reveal, maybe, and a fundamental principle of physics that often catches people off guard, is this. In a steady state, that is, when your sauna has reached and is comfortably maintaining its desired high temperature, an insulated wall does not retain more heat in terms of power in watts than an uninsulated wall.
Wait, what? Seriously?
Seriously.
Yeah.
This is truly counterintuitive, but it's how physics works. All dissipated power will eventually leave the sauna. Heat always flows from hot to cold. The key clarification, and why insulation is so vital, is that for the same internal heating and comfortable temperature, an insulated wall requires less power to maintain that temperature than an uninsulated wall. The true goal of insulation isn't to trap heat forever, which is impossible. Instead, it's to ensure that heat leaves via the controlled, slow process of thermal resistance through the walls rather than through uncontrolled leaks, drafts, and rapid conduction, which would make your sauna incredibly inefficient and expensive to run.
Okay. So it's about efficiency, maintaining the heat, not necessarily trapping more of it indefinitely or heating faster beyond a point.
Precisely. Given this nuance, it might actually be beneficial to have increased insulation for the ceiling. Since it's generally the hottest average surface in the sauna, with hotter rising, for instance, you might use 5 to 7.5 centimeters for the walls and a thicker 10 centimeters for the ceiling. Now, if you're using PIR, those rigid foam boards we talked about, because of its significantly lower thermal conductivity, around 0.023 WMK compared to about 0.045 for glass wool, you can achieve excellent insulation with much thinner thicknesses, sometimes just 3 centimeters to 5 centimeters. However, this absolutely requires everything to be hermetically sealed, prevent any air leaks. Even tiny gaps can drastically reduce its effectiveness. Why this matters to you is that this insight completely changes how you think about insulation. It's not about trapping heat forever. It's about making the heating process incredibly efficient and maintaining comfortable internal temperatures with significantly less energy. It's about smart, physics-driven design, not just brute force thickness.
Let's put all this talk of insulation into perspective with some formal standards. Give us some numbers. According to the EN 15821 standard, which is the European safety standard specifically for saunas, the thermal resistance of a sauna wall should be at least 1.875 to 2.5 meter DLGW. So to give you a practical example, for rock roll with a thermal conductivity of roughly 0.045 WMK, this translates to an insulation thickness of about 7.5 centimeters to 10 centimeters. For a truly striking comparison, think about a typical 20-centimeter thick, uninsulated concrete wall, like you might find in an older building. That only has a thermal resistance of about 0.1 meter at RKW.
A huge difference.
Massive.
And here's where we get to a crucial comparison that provides a fantastic aha moment, a real paradigm shift in how you might think about building performance. If we look at general European building regulations, for instance, French regulations from 2023, they require a wall to have a thermal resistance of at least 3.7 meter kW, which is significantly higher than what's specified for a sauna.
Right, much higher. So why the difference? This raises an important question.
Exactly. Why are these numbers so different? The answer lies in their intended use. Those regulations for homes apply to continuously operating buildings, with much higher ongoing energy consumption over 24 hours a day, 365 days a year. Your personal sauna, on the other hand, operates sporadically, maybe for an hour or two a day, a few times a week. More importantly, comparing thermal resistances without considering thermal inertia is incredibly misleading for a sauna. High-inertia building walls, like heavily insulated concrete, would drastically lengthen sauna heating times. They absorb so much heat themselves before the air inside even begins to warm up significantly. Such materials are simply unsuitable for a sauna, where rapid heating and a quick, intense thermal experience are desired. This is a fantastic example of why what's good for your home isn't necessarily good for your sauna. Fundamentally different operational goals and the specific transient thermal physics involved.
That makes perfect sense. Different tools for different jobs. All right, let's talk about the absolute heart of your sauna, the stove. And here, safety is not just paramount, it's non-negotiable. A safety barrier around the stove is an incredibly useful addition. Acts as a physical guard, preventing accidental falls onto that scorching hot surface. Serious injuries could result. And this barrier absolutely must be made of wood, never metal, to avoid severe contact burns. Metal gets dangerously hot.
Very dangerously hot.
In terms of placement, for both practicality and efficient heat distribution, the stove is usually installed conveniently in a corner of the sauna.
Right. And to further enhance both safety and thermal insulation for the surrounding structure, you can strategically place materials like bricks, concrete, cellular concrete, or even lime between the very hot stove and the interior wood wall. This protects the wood from direct, intense radiative heat, prevents scorching or even fire risks over time. Interestingly, cellular concrete offers a particular advantage here. It's significantly lighter and causes less thermal pumping, meaning it absorbs, and then slowly releases less heat itself, which contributes to a faster temperature rise inside the sauna.
So it heats up quicker.
Yeah. The stove and its stones already provide more than sufficient thermal inertia. No need to add more mass that would simply slow down your heating time and waste energy. And for those considering a traditional wood-burning stove, which offers that unique, deep heat, careful and meticulous attention must be paid to the chimney's passage through the roof. This is critical not only to prevent frustrating and damaging water infiltration, but more importantly, to mitigate significant fire risks associated with high temperatures and combustible materials right near the chimney. These details are critical for both safety and optimal performance, ensuring your sauna is effectively hot and a hazard-free zone where you can truly relax without worry.
Now, here's a crucial and perhaps somewhat paradoxical aspect of sauna design: ventilation. It is undeniably the primary source of heat loss in a sauna. You're deliberately letting hot air out. Yet, and this is absolutely critical, it must not be stopped or even significantly restricted. That might sound completely counterintuitive when you're trying desperately to keep heat in, but ventilation is absolutely essential for two vital reasons. Occupant comfort, preventing a suffocating feeling, and maintaining good air quality. Ensuring you're breathing fresh, clean air, not stale, oxygen-depleted air.
You're absolutely right. It's a critical balancing act where optimal health and comfort take precedence over purely maximizing heat retention. Good ventilation design involves incorporating easily openable and closable vents to facilitate natural convective air circulation. That's fresh, cooler air flowing in from outside, typically low near the stove, and stale, hot, humid air flowing out from inside, usually high up on the opposite wall. For a typical 8 cubic meter sauna, vents around 10 by 10 centimeters are suitable. For saunas of different sizes, a good guideline is to aim for an air velocity of approximately 1 meter per second at around 85 degrees C. You can then calculate the necessary vent size using the simple formula. Flow rate equals velocity multiplied by area.
Okay, a bit of math involved.
A little bit. In terms of air changes, typical ventilation rates are quite robust, ranging between 3 to 8 air changes per hour, with 6 volumes per hour being a commonly cited figure in international standards for good practice. And when installing these, it's vital to thoroughly insulate and waterproof the ventilation passages through your walls. Prevent uncontrolled heat loss and potential moisture problems within the wall structure. This underscores a fundamental truth: you can't prevent all heat from escaping, nor should you try. The goal is to manage it intelligently, making sure it exits efficiently and safely, while simultaneously ensuring a constant supply of fresh, invigorating air for your comfort, health, and overall enjoyment. It's about controlled efficiency and healthy air, not perfect, stifling retention.
Okay, this is a truly contentious and fascinating topic in the sauna world. Ceiling height. You'll often hear seemingly sensible recommendations not to build a sauna with too high a ceiling. The reasons given sound very practical. Limits the overall volume you need to heat, which in theory saves energy and time. It also aims to prevent an unnecessary concentration of heat at the very top heat that the occupants sitting lower down simply can't effectively enjoy. Practical guidance often suggests the distance between the top bench and the ceiling should not exceed 120 centimeters. And a good old-fashioned tip: leave about 2 fist widths between your head and the ceiling. This is partly to avoid uncomfortable air currents near the ceiling, which can be quite noticeable in that uppermost layer of superheated air, and also for a bit of psychological comfort, avoiding that too close or even claustrophobic feeling.
This is indeed where deep-rooted tradition often butts heads with modern, sometimes overly simplified practicality, leads to a truly significant debate. Let's introduce what's known as the law of scheme, or more commonly in its original Finnish, the Loyoli law. This isn't just a quaint term. It's a fundamental principle rooted in centuries of Finnish tradition. Dictates optimal heat and steam distribution for the most authentic and effective experience.
The Loyoli law.
Okay.
This principle dictates that for an authentic and effective experience, the occupant's feet should be at the level of, or even slightly above, say, 10 centimeters or more, the stove stones. This inherently leads to relatively high saunas, often much higher than modern compact designs. A greater height also offers practical benefits that are often overlooked. It helps minimize significant heat loss when the door opens, as the colder air rushes in at a lower level. It also reduces cold drafts on occupants by allowing that cooler incoming air to sink to the bottom without directly impacting those on the benches.
So higher ceilings aren't just wasted space according to this law.
Not at all. To truly appreciate the implications, consider some basic human measurements anthropometric data. For women, average foot-to-knee height, 0.50 to 0.59 meters. Foot-to-eye height, 1.08 to 1.24 meters. For men, slightly higher, 0.54 to 0.64 meters foot-to-knee, and 1.18 to 1.34 meters foot-to-eye. These figures are absolutely crucial when determining comfortable bench heights in relation to the stove and ultimately the ceiling, ensuring your head is well below that hottest, most intense air layer.
Makes sense. You don't want your head in the blast furnace zone.
Exactly. Now, when we look at various conflicting standards and manufacturer recommendations, the differences become quite stark and illustrate this debate perfectly. For instance, the EN 15821 standard, the European safety standard, suggests sauna heights ranging from 1.9 meter, 2.1 meters, or 2.3 meters. Finnish manufacturer Harvio recommends a minimum of 1.98 meters, normal 2.13 meters, max 2.44 meter. Swedish manufacturer Tylo advises not smaller than 1.9 meters, not larger than 2.2 meters. And one particular reference just states not exceeding 2.1 meters, so quite a range.
Yeah, all over the place.
The important thing to understand is that many of these values, especially from non-Finnish sources, are often debatable because they don't strictly adhere to the traditional law of steam. For example, the American UL 875 standard, primarily an electrical safety standard, recommends relatively low sauna heights. This is partly due to a focus on reducing steps and fall risks, a different design philosophy than optimizing the thermal experience. It also often places the thermostat sensor above the stove, which, in practice, leads to lower than Nordic temperatures at the occupant level, because the heat is regulated prematurely based on the hottest point, not the most comfortable average.
So the thermostat placement trick matters too.
Big time. And even a major Finnish manufacturer like Harvia, in their English-language documents, offers designs that don't strictly follow the Loyoli law, particularly with open stoves like their Cilindro PC70, often to cater to different market preferences or steel constraints. Let's do a quick calculation to show the Loyoli law's real impact on height. For classic Harvia M3 wood stove, about 72 centimeters high. The footbenches would ideally be placed at 72 centimeters or even 82 centimeters, 10 centimeters above the stones to put your feet in that optimal heat zone. Sitting benches would then be roughly 45 centimeters higher, putting them at about 117 to 127 centimeters. And the ceiling, to allow for proper air circulation, head clearance, and that essential comfort zone above your head, would need to be 100 to 120 centimeters above that. This leads to an overall ceiling height of approximately 217 to 147 centimeters, so 2.2 to almost 2.5 meters.
Quite high then.
Quite high. And for larger stoves, like the Harvia Cilindro PC70, which stands at 93 centimeters, the required ceiling height would be even greater, around 238 to 268 centimeters, pushing towards 2.5 to 2.7 meters. So the takeaway here is this. Ultimately, you'll build your sauna to your desires and means. But understanding these different philosophies and the principles behind them helps you make incredibly informed choices about your ideal height. It's not just about what physically fits, but what delivers the most authentic, comfortable, and therapeutic experience for you. Hashtag 4.4, the problem of thermal gradients in shorter saunas.
That's a fantastic point about balancing tradition with the practical realities of modern spaces. But what happens if, despite these guidelines, your ceiling ends up being on the lower side? Or maybe you're using a garden shed as a base, like we'll discuss later. What kind of experience can you truly expect then, particularly regarding heat distribution? Is it just worse?
Okay. If the ceiling is too low, you're highly likely to encounter a significant issue with pronounced thermal gradients. That layering of heat. In experimental saunas with relatively low heights, say around 2 meters, temperatures measured at head, hip, and foot levels show distinct, sometimes uncomfortable differences. You might see 90 degrees C at head level, 85 degrees C at hip level, and a much cooler 60-65 degrees C at foot level.
So cold feet, hot head.
Pretty much. This steep gradient can push the boundaries of what's considered thermally comfortable. Your feet might feel too cold while your head is scorching. Generally, we observe that the bottom third of the sauna is often relatively cold and should ideally be avoided for optimal comfort. It simply doesn't get hot enough to be truly therapeutic down there. However, Here's a simple yet highly effective solution to experience a very low or even near zero thermal gradient, even in a shorter sauna. Lie down.
Ah,
Yeah.
just change your orientation.
Yeah.
Exactly. When you recline on a bench, horizontal thermal gradients are very, very small. This allows for a nearly homogeneous temperature throughout your entire body, enveloping you in consistent heat, even in lower height saunas that don't strictly follow the law of steam. So if you're building a sauna with a more constrained height, designing benches that are wide enough and sturdy enough to allow for comfortable lying positions can significantly enhance the experience, transforming a potentially uneven heat distribution into a uniform, blissful warmth. On a cautionary note, please never use standard market benches or chairs, not specifically designed for saunas. They are typically far too low. This would prevent occupants from benefiting from the heat and steam due to that pronounced stratification, where hot air and steam naturally rise, leaving the lower levels much cooler and less effective. Why this matters to you is that this is a great practical tip for maximizing comfort in any sauna, but especially if your design ends up being on the shorter side. Sometimes the simplest solution, like changing your posture, is indeed the best.
We've covered a lot about what to do and how to optimize the design. Now let's briefly touch on what not to do, especially concerning placement. Where should you absolutely definitively avoid building your sauna?
Right. Building a sauna in areas like a garage or a typical basement is generally a bad idea, often counterproductive to the very essence of a relaxing experience. These locations often present inherent challenges that are, well, antithetical to a good sauna experience. You want to rigorously avoid humid, poorly ventilated areas, disturbing odors from chemicals or vehicles or elements that could cause claustrophobia or feelings of unease. A sauna should be a pristine, calm, and rejuvenating space. And these types of environments can quickly undermine that. For instance, a musty basement or a garage with gasoline fumes instantly detracts from any sense of purity or well-being. So when picking your spot, think carefully about the ambient conditions. Fresh air circulation, minimal moisture, and an overall calm, inviting, quiet atmosphere are paramount. You're not just building a room, you're crafting an environment. Hashtag tag 5. Comfort, accessibility, and the finishing touches.
Okay, let's talk about where you'll spend most of your time in the sauna, the benches. These are, of course, made of wood. You have various species to choose from: spruce, pine, cedar, aspen, hemlock, samba, poplar, abachi. The material isn't just about looks, it's absolutely key for comfort, temperature regulation, and safety.
Indeed. The design and construction of the benches are truly crucial for a comfortable, authentic, and safe sauna experience. A typical and highly effective design features 2 stages or levels of benches. You'll usually find a lower bench positioned at approximately 50 centimeters high, primarily for resting your feet comfortably, or for sitting if you desire a slightly cooler, gentler heat. Above that, an upper bench is usually around 90 to 97 centimeters high, providing the optimal height for comfortable sitting in the hotter air layer. While a lower height of 75 centimeters is also possible for the upper bench, especially with sloped ceilings, it might not fully respect that law of steam we discussed, which ideally places your feet closer to the stones.
Right, getting the feet up high.
Exactly. Beyond height, and this is non-negotiable, the benches must be incredibly strong and robust, enough to safely support occupants, even multiple people. A minimum plank thickness of 2.2 centimeters is required. But for truly robust benches that inspire confidence and feel substantial, thicker planks, up to 5 centimeters, are highly recommended. Just to give you a practical sense of the engineering, let's just say for a typical bench setup supporting a reasonable weight, the stresses involved are well within the limits of construction wood. They build these things with very generous safety margins.
Good to know.
Absolutely. You can lean back or lie down with complete confidence. Now, when sitting and foot benches are placed at higher levels to adhere to the Loyalty Law, adding lower, intermediate benches can be incredibly useful for easier access. Makes the sauna more inviting and safe for everyone, especially children or those with reduced mobility. 3 levels of benches are actually quite common. And for optimal comfort, whether you're sitting upright or lying down for that homogeneous heat experience, benches should be at least 60 centimeters wide or deep. Gives you room. This blend of practical, thoughtful design and robust structural engineering ensures both comfort and safety for every user. Allows for a truly relaxing and worry-free experience. Hashtag tag 5.2 accessibility and inclusivity.
It's also great to highlight how modern sauna design is evolving to be more inclusive. There's a really positive emphasis on adapting these wonderful spaces so everyone can enjoy them.
Absolutely. This is a critical and welcome development. A sauna can be thoughtfully adapted for people with reduced mobility. integrating features like wider doorways, reinforced grab bars, maybe even specialized transfer benches. This is an increasingly important consideration for inclusivity, ensuring that the profound physical and mental benefits of sauna bathing are accessible to a wider range of individuals, irrespective of their physical capabilities. It's about designing with everyone in mind, right from the outset, to truly embody the spirit of wellness for all.
Beyond the structure and the raw heat, let's not forget the sensory experience that truly completes a sauna. The right ambiance, particularly lighting, plays a huge role in transforming a simple hot room into a sanctuary. Lighting, both inside and outside, is important for practical reasons. You need to see where you're going, especially in a steamy environment. But more crucially, it's about crafting that desired atmosphere. Soft, subdued lighting is generally preferred. Contributes immensely to a sense of calm, introspection, deep relaxation. Harsh overhead lights would completely break the spell.
Totally kill the mood.
Right. You could even consider solar-powered lighting for an eco-friendly, discreet touch. Adds to the natural feel.
And then there are all those essential accessories and thoughtful touches that elevate a basic hot room into a holistic wellness experience. Every sauna absolutely needs the thermometer, typically an alcohol or electronic one with a clear scale, 0 degrees C to 120 degrees usually, though some electric stoves have integrated thermostats. For the authentic steam experience, that loyally, a water bucket and a sturdy wooden ladle are an absolute must for dousing the hot stones. An hourglass is a traditional, elegant, non-intrusive way to time your sessions. Usually set for 5 to 20 minutes, lets you relax without constantly checking a clock.
Nice and low tech.
Exactly. For comfort, wooden footrests and contoured headrests are wonderful, ergonomic additions. Hygiene is key, so having solid or liquid soap and a natural loofah glove readily available for post-sauna washing is practical and inviting. Essential oils, carefully selected, can be used sparingly to infuse the steam with subtle, calming, or invigorating notes. If you have a traditional wood stove, a readily accessible pile of wood, and the necessary tools to manipulate the stove door without burns are absolutely essential for safety and operation. Towel rack, useful, and those unique felt hats you sometimes see.
Yeah, what's the deal with those?
They're actually very practical. Protect your head, hair, ears from the most intense heat. Allows you to stay in longer and more comfortably. Hydration is paramount, so a bucket of cool water for drinks is a thoughtful, necessary touch. And as a cultural touch, in Russia, for instance, it's common to wear topachkis, sandals, to prevent slipping or burning feet on hot surfaces. Highlights the importance of every detail. Why this matters is that these seemingly small details contribute significantly to the overall ritual and profound enjoyment. Transforms a simple hot room into a complete wellness experience.
Let's turn our attention to the sauna door. It's far more than just an entry point. Plays a critical dual role in both insulation and, crucially, safety.
Yeah.
A well-constructed wooden door is generally preferable to a full glass door because it's significantly more insulating. Helps keep that precious heat contained. And it's absolutely vital to properly insulate the door seals all around the frame, prevent hot air leaks, and, just as importantly, prevent cold air from seeping in. Creates uncomfortable drafts, wastes energy.
You've highlighted the practical and efficiency aspects, but I want to underscore a truly crucial and fundamental safety rule for any sauna door. For obvious and fundamental safety reasons, the sauna door must not be lockable from either the inside or the outside.
Right. Cannot lock. Period.
Period. This is a non-negotiable feature, a basic human safety requirement, explicitly designed to prevent entrapment in what is an extreme thermal environment. In an emergency, or if someone inside becomes unwell, disoriented, or just needs to exit quickly, the door must always be easily and immediately opened from either side. No fumbling with keys, latches, complex mechanisms. It should operate with a simple pull or push, often using just a magnetic latch. This is a basic human safety feature that should never, ever be compromised in any sauna design or construction.
So we've designed and built what sounds like the perfect sauna itself, but what about the spaces around the sauna? How can we think holistically and enhance the overall experience even further, extending the sanctuary beyond just the hot room?
Thinking beyond just the hot room itself is absolutely key to creating a truly holistic and fulfilling sauna experience. It's incredibly useful, almost essential, to build a second room, a buffer zone, or antechamber, especially for outdoor saunas. This space serves multiple vital functions. It's a dedicated place for changing clothes without feeling rushed or exposed, for a moment of quiet relaxation before or after your session, or for a gradual, gentle cool-down. Furthermore, essential facilities like showers or any convenient water point are absolutely necessary for cooling down rapidly, rinsing off sweat, proper washing.
The entire setup, including these ancillary spaces, should ideally be situated in a quiet, serene environment, contributing to the overall calming, relaxing atmosphere. And for an indoor sauna, there's a specific and clever design philosophy. Leave about a 20 mm air gap space between the sauna walls and the surrounding room walls. The sauna should essentially be designed as a room within a room.
Ah, okay. Detached from the main structure.
Exactly. This separation helps with both acoustics, dampening sound, and crucially, with thermal management. Allows the sauna structure to expand and contract freely, and ensuring proper ventilation around its exterior. These elements powerfully demonstrate that the true sauna experience extends far beyond just the hot room itself, encompasses a comprehensive, thoughtful approach to relaxation, hygiene, and full recovery, truly making it a personal retreat. Tag 6. Practical applications and critical thinking.
Okay, for the enthusiastic DIYers and those looking for a more accessible entry point into sauna ownership, building a full-fledged custom sauna might seem like a huge, intimidating undertaking. But there's actually a simpler, more budget-friendly starting point you might not have considered. A bit of a hack, maybe?
Indeed. One of the simplest and most ingenious ways to approach building a sauna, especially if you're on a budget or have limited construction experience, is to repurpose an existing structure, specifically by starting with a robust garden shed of the desired size. You then transform it by insulating it from the inside with, say, 5 to 10 centimeters of rock wool, and add your chosen interior wooden wall, perhaps 1 centimeter thick, to neatly sandwich that rock wool in place. To ensure proper vapor management, which is crucial, it can be useful to add a breathable rain screen film between the exterior wall of the shed and the rock wool. And then, crucially, you'd install that aluminum vapor barrier between the rock wool and your new interior wood wall, shiny side in. And this vapor barrier must be hermetically sealed with aluminum adhesive tape at all seams and edges. Protect the insulation from moisture from both sides. Prevent harmful condensation.
So basically, build a sauna box inside the shed box.
Pretty much. Now, a key caveat to this method is that garden sheds often come with relatively low ceiling heights. This might make it difficult to fully adhere to that law of steam we discussed earlier, which often requires higher ceilings for optimal loyalty and thermal comfort, particularly for upright seating. So while this offers a practical, budget-friendly, and often much quicker entry point for building a sauna, it's important for you to be aware of these potential compromises, especially regarding ceiling height and traditional loyalty law adherence. It's a trade-off, certainly, but one that can still lead to a very enjoyable and effective sauna experience if you understand its limitations and design around them. Perhaps, as we mentioned, by focusing on a lying down experience. Tag 6.2, material purity and sustainability.
As we embark on building these deeply personal sanctuaries, it's incredibly important to consider the broader impact of our material choices, not just on the sauna's immediate performance, but crucially, on our own long-term health and the environment.
This is a critical point that cannot be overstated. For the interior of your sauna, it is paramount to use only untreated wood. This is to rigorously avoid any emissions of harmful gases and particles of formaldehyde, other VOCs, especially at those high sauna temperatures. When wood is heated, any chemicals or treatments applied to it can easily volatilize into the air you're breathing, potentially causing respiratory irritation or worse. For the exterior, however, where weather resistance is a primary concern, the wood can and often should be treated to protect it from moisture, pests, UV degradation. Beyond your personal health, which is obviously paramount, ideally, we should all strive to use only wood and other materials from eco-responsible and sustainably managed sources. This commitment is about both your personal health during your sessions and minimizing your environmental impact, ensuring your relaxation doesn't come at a cost to the planet, making your sanctuary truly holistic.
Okay, here's where it gets really interesting, and it ties into a crucial skill we hone in every deep dive: critical thinking about the information we receive. When you're planning a sauna build, you'll naturally turn to experts, installers, manufacturers for advice. That's smart. They have a wealth of knowledge. But a critical, discerning perspective is absolutely essential. You can't just take everything at face value.
You're absolutely right. Manufacturers and sellers of sauna equipment, stoves, materials, accessories are indeed excellent sources of technical information and practical advice, often possess deep, specialized knowledge of their products. However, and this is the crucial caveat, every informed consumer must remember, always keep in mind that they are commercial entities. Their primary goal is to sell their products.
Right. They want your money.
At the end of the day, yes, their advice, while often well-intentioned and technically accurate regarding their specific offerings, might also be subtly biased. It might not always be entirely scientifically founded outside their product's immediate scope.
And ultimately, it's geared towards their commercial interests rather than exclusively yours. Let me give you a classic example. If a seller recommends replacing all your sauna stones very regularly, maybe every year or two, you might want to pause and rethink that.
Sounds expensive.
It can be. While replacing a few fractured stones is perfectly fine to maintain efficient heating and steam production. Replacing all of them too frequently is usually unnecessary, and frankly, often more about selling you new stones than genuinely improving your sauna experience. This raises an important question. What is the underlying motivation for this specific piece of advice? Is it truly for optimal performance or for repeat sales?
Always ask why.
Always, more broadly, always maintain a critical mind towards all manufacturer claims, and certainly towards any self-proclaimed gurus who make extravagant, unsubstantiated health claims about saunas.
Oh.
Always demand serious, peer-reviewed scientific references to back up such assertions. When it comes to major reputable brands, names like Harvia Finish, 1950 Narvi, another Finnish brand, 1937, acquired Kota and Aito in 2010, and Tailu Swedish, 1950, are prominent. Sawo, for instance, is an Indonesian brand that's gained recognition. These companies produce quality products. But understanding their commercial context helps you filter their advice effectively and make truly informed decisions for your sauna, ensuring you build wisely and sustainably. #outro.
Wow, what a journey. We've truly taken a deep dive into the fascinating, intricate world of sauna construction today. We've covered everything from, the surprising historical sizes of saunas to the nuanced physics of insulation and steam dynamics. We navigated the great ceiling height debate and the Loyalty Law and even discussed how to be a smart, critical consumer of information. It's abundantly clear there's so much more to a sauna than just a hot room. So much more. We've reinforced that delicate balance between traditional design wisdom and modern physics, explored the profound importance of material choices for both health and performance, and highlighted the critical role of thoughtful ventilation and strategic height in creating a truly authentic, efficient, and comfortable experience. Hopefully, you now feel much more equipped, not just with facts, but with the reasons behind them, to confidently envision and perhaps even build your ideal sauna sanctuary.
Yeah, and if we connect this to the bigger picture, it's clear that building a sauna is this rich, rewarding blend of engineering principles, cherished tradition, and deeply personal preference. The ultimate goal, regardless of the specific choices you make, is always to create a space where the heat, steam, and fresh air flow harmonize perfectly for maximum well-being, delivering a truly rejuvenating and introspective experience. Now, considering all we've discussed about thermal gradients and the power of horizontal heat distribution, here's a thought for you to mull over. How might a sauna designed purely for lying down offer a fundamentally different and perhaps even superior thermal experience compared to one primarily built for upright seating, regardless of its height? It really makes you think about the true essence of comfort, doesn't it? Keep exploring, keep questioning, and enjoy the journey to your perfect sweat.